Right now, our first upcoming speaker is Peter Stensgaard Hansen. He is the managing partner at Subsea Cloud Partners, and he'll be talking about scalable and sustainable AI infrastructure on the seabed or on the riverbed, if you want to. Basically, Peter's talk will be exploring how Europe's offshore technologies can enable scalable and sustainable AI infrastructure by placing data centers on the seabed. So without further ado, I want to call Peter to the stage.
Thank you, everyone. I met a participant yesterday, and she said that she goes to these conferences to learn new things, new perspectives, and I hope I can bring this today, because I am neither a data scientist. I know very little about servers, networks, fiber optics, and so on. But I know something about offshore development. And I would like to spend some minutes show you a dream or vision. I actually got quite tangible next year to build a massive and impressive AI infrastructure in the North Sea. And when I show this in the North Sea, I look out here and look at the Donau River. It could also be there. Just for those that are from the local area, this technology is applicable for everywhere where there's water. So let me just take you through our story and some perspectives on what's going on in European data centers. And trying to make this work. Yeah. So instead of coming from computers and data science, I come from 10, 15 years of offshore wind, and I have built a lot of Ørsted, which is the world's largest offshore wind develops operational systems. And in the recent years, offshore wind has been struggling. And this is a picture from our German situation, where we see where Ørsted, offshore wind developers, see that you have a period with high subsidy periods where there's gold and diamonds, and then suddenly you come out of the subsidy with your wind farm, and it's worth next to nothing. At the same time, in the green transformation in offshore wind, we saw interest rates going up, stopping all new build-outs of offshore wind. And together with that, you have a situation where you start having significant energy fluctuation. So this was the dilemma I faced up in Ørsted and was trying to figure out how to solve that. And then the idea came to, how does data centers fit into this world here? And if I look at the situation in Europe for data centers, we are about to pass 150 terawatt hours of use. So that's 3% of all Europe's energy that will go into data centers. But on a global scale, I think that gives more perspective. We're about to pass what is 1,000 terawatt hours of energy use. So that's all the energy production of Japan, as a really big country, goes into powering the world's data centers. And it's only going, well, in the wrong direction. In Europe, we are spending 40% of that energy just for cooling of our data centers. So if I calculate that back into a CO2 emission, that's equal to 17 million households of CO2 equivalent into CO2 into the air. So that's all households of Denmark, Norway, Sweden, Holland, Belgium, and Serbia together. So I think it's fantastic what we're trying to do with electrical cars and saving a bit on LED lights and so on. But our data centers are about to kill our green transformation. At the same time, there was a declaration during the COVID where a lot of the countries around the North Sea met in Esbjerg on the west coast of Denmark and pledged to put 150 gigawatts of offshore energy into the North Sea. But they just forgot to give any money, any financial abilities for the TSOs, those, the grid operators, to be able to export that energy into the grid. So the European green transformation is under pressure. There's a massive pressure from data centers coming in. There's a massive pressure from building out new green infrastructure. So what to do about that? Because I'm sure maybe it's more your alley this year, right? What I've seen in many places is that it costs 10 times the amount of energy to do a ChatGPT prompt as it does to do a Google search. And now we see with ChatGPT coming in with their new search function, right? Use ChatGPT instead of Google to search for your things online. We just see that AI is going to require a shitload of energy. We see hyperscalers starting massively investing into nuclear power, building nuclear power plants next to their data centers. It's going to change the world quite a lot, and it's going to put pressure on our transformation. In Europe, we are responding to this. The European Union is trying to say, listen, we need to reduce energy by 11.7% toward 2030. But again, the data centers struggle to follow this. And this graph here shows the PUE is a power unit efficiency. So when you're PUE 1, just to explain that, then all your power goes into running your GPU, your compute. Whatever is above 1, percentage-wise, is added into, well, light, cooling, and so on. So yeah, we really struggle, and you see on the graph here, over the last years, we really struggle breaking that curve for efficiency. And Germany is leading the path on new regulations. New data centers in Germany must break that curve. They must be maximum at 20% spending energy above the direct compute capacity. And we are going to see a transformation of European data centers that need to modernize, close, be rebuilt in new ways. So this was the dilemma that I saw into a year ago. And then we looked at the North Sea. Ever since the Viking Age, the sea, or maybe before that even, the sea has given and has taken. And particularly since the 70s, the North Sea has delivered solutions to North European, but also Mediterranean European countries' energy needs. First with oil and gas in the 70s, building fantastic engineering challenges as a crazy projects out there. One of my first projects was on Norway's second largest gas field, Ormen Lange, where someone in the late 80s had that brain dead idea to spend 80 billion Norwegian crowns trying to build a production center 3 kilometers under the water that should stand there for 50 years, never being maintained. So there's just some things in the oil and gas industry that has pushed the boundaries for humans' ability to create amazing wonders. In the 2000s came the first industrial scale offshore wind structures with the Hornsea in Denmark, but now there are 20 gigawatts of power in North Sea. And we believe this year, and this decade, we're going to see data centers as the next step for the North Sea, or generally in European context. So we've been working on this for some years, my colleagues. And we built these 20-foot containers here. Maybe some of you have heard about the Microsoft Natic project some years ago, where Microsoft also tried this activity. And they did well, I think. But they also took some learnings in the first time. They had air inside, made it float, instead of had a complicated system to keep it down. They saw corrosion and so on. But they also recognized that the idea was strong. I think why Microsoft did not continue either was that they did not have a new NVIDIA Blackwell B200 into their eyesight, but that's coming now. We see now that the newest NVIDIA Blackwell compute can only be run with a liquid cooling, so there has to be some kind of fluid around the chips. And as NVIDIA calls out saying, the next one can only be what's called immersive cooling. So that you take the server and put it into an oil to be able to manage the massive amount of heat radiation that these server components deliver. So what we do is we have again, we are not for the computer world. We are from oil and gas people. So we built these 20-foot containers. We built them for a few military units and a few governments already. And inside, it's filled with this liquid, this oil, where we can have 16 racks inside. We can actually have what's called an NVIDIA superpod inside each of the pods. And we do not add any artificial cooling to it. It's all run by the sea. As the water passes through, as it places down, as water passes through, the sea is very eager to absorb heat. As you remember from your physics, chemistry in your school time, all materials intend to go to their gas forms. And water intends, the whole purpose of water is to turn into a cloud. And you feel that when you go into the sea and you step out, right, you feel your feet gets cold. That's because water is hungry to absorb energy. It wants to turn into a cloud. It's the same dynamics that we use here. So we don't add any additional cooling. We let the sea do it. We are able to use the difference between the inside heat, 45 degrees, outside 12 degrees, and recycle some of the heat back to our small electricity current into the transformer. And lastly, it's very important for us to be closely located with energy production. Every time a handful of transformers passes through a transformer station, you lose 2, 3, 4% of the power. So that's also part of it, to really get close with energy production. So you talk about moving AI to people. I think you should talk about moving AI to where energy is produced. One of the things as well is, and of course I come from Ørsted, that's creating a world running on green energy, and that still follows me today. And I'm sad to see such a news like here from Bloomberg, right? 1 out of 10 AI companies to follow is European. There are, 7 Americans, 1 Canadian, 1 Chinese, right? Mistral is the only one that Bloomberg called out earlier this year to say this is an AI company that's worth to follow. And this is also part of it. It is to create European capacity to catch up with the Americans, with the Chinese, in a way that Europe has done before, smart, sustainable solutions. So we do envisage to build our super AI cluster in the North Sea and in the Baltic Sea, and when we get to it, also in the Mediterranean Sea. But as I said in the beginning, this is not only about the sea, as I could really work in the rivers, as we see German cities calling for this solution as well, down to the rivers, reintegrating into district heating and so on. So this North Sea here, as it's back to this, that 150 gigawatt was placed out. So the vision is to, over the next 6 years, to build data centers along the coastline, and then ultimately build a super cluster together with a North Sea oil and gas field out far. There's power, there's fiber, and there's of course a lot of cooling. And we start with cluster 1, where we build along the Danish west coast in 4 harbors. And more specifically, next year we are going to deploy the first of our 4 pods. So this will be the first public project that we will do that will be publicly available to come and see. So 2 pods in the port of Hansen, which is the northern part of west coast, and 2 ports in Esbjerg, which is in the southwestern corner. And each of them have strong interconnectors on fiber to Norway and to the rest of the world from there. And most of all, they have a lot of access to power, because there's a massive amount of power in Denmark coming from the North Sea and also along the coastline for onshore wind. This is how it looks like. So the ambitious plan is to build this as soon as possible. I hear people talking about that it takes 2, 4, 5 years to build a data center. I don't know. We mass produce these on a shipyard in Norway. So I don't know what the problem is. It's a bit funny to come from a different industry where you used to build huge, complicated infrastructure projects, and you come into industry and say, yeah, there's no power, there's no land. I don't know. Have you looked at a map? Have you tried to open the map and see the electricity grid? See how it looks like. Try to place yourself near where there is power production. Try to place yourself, in the sea. There's lots of space. Maybe my last slide here. So this is how it looks like, and I also took our 3D model here. So it stands here on 4 legs in this model here, with a suction bucket known from oil and gas. It's being maintained every 3 years. So I hear a lot of customers saying, "Yeah, we like to go down to the basement and look at change the hard disk and look at the bleeps and the beeps and so on." No, that's not going to be possible here. So the operation model is to put it down there and put it down for 3 years. And we do that because we see that this immersive cooling, this liquid, sustains the hardware much better than air cooling, where there's no opportunity for the electrons to pass through or board. This temperature is stable. It just sustains what we see 30% longer than air-cooled data centers. And then ultimately place it offshore, where you already have the build-out for your offshore transformer stations. And when the wind blows, the energy is passed through the transformer station down on the seabed for your build-out. And when the wind does not blow, then the cable is there. People say, can you pull? What can you? Is there not a one-way train? No, an energy cable goes 2 ways. It holds a current inside the cable. So if you don't produce energy from the turbine, then you pull from the land. I think we need to do radical new thinking in Europe. Back to this NVIDIA calling for immersive cooling. the VP of NVIDIA said, Europe, you're so behind. You're going to be run over once more by the Americans and the Chinese. You need to think differently when it comes to your data centers and the way to think about AI. We do see, who is this for? It is to build for American hyperscalers side. We need in Europe to find new ways how to catch up in the very capital-intensive games. Yeah, we don't have hyperscalers in that size. We don't have crypto miners in that size, which are right now running these as a GPU build-outs like crazy. You saw Elon Musk and his Colossus project building, in 17, 19 days, a giga AI factory, right? And that's what they can do. I think we need to really think hard in Europe what we should do. And at least now in Denmark, there is a lot of conversation about what is the European play here. And I came last week from a discussion with the government in Denmark, saying, we cannot, catch up on the LLM game. We must think out how do we do specific models, and I hear a lot of the companies here as are doing specific models for some specific problem. We cannot catch up on the infrastructure. They have, built the infrastructure for GPU capacity. They have built the LLM capacity. In Europe, we need to find a way how to compete on the application layer of these technologies. So with those words, I will happy to take some questions if you have, and how this could maybe apply in a Serbian context.
Are there any questions? Feel free to. Okay, and then our volunteers will come and.
Hello, thanks for the talk. I know it's very early in the world of AI, but do you see the energy demand kind of plateauing at a certain point? Because I know that the statistic gets thrown around about, one ChatGPT query is 10 Google queries, yeah. But if I have to compare two pieces of information, I am doing 10 Google queries and going to 10 crappy websites, which could be just one question to an LLM. If I have to data label 100 pictures, then I'm doing it locally in my data center. I don't need to use all the CDNs and all the data centers of the world. So we are, at a certain point at least, going to save or conserve power as well, I suppose. When do you see that happening, and any views on that?
And I think that there's a lot of challenge here on there's a lot of interest also in the, let's say, in the stock market about these projections here, as we see. When does the hype fade, and when does the next transformation come? I do think that we will see new chips coming out that will be more energy efficient, that will take off some of the lift in the energy demand. We also will see, as Sam Altman said, the OpenAI technology, how to just hammer energy into our LLM, comes to a peak. Right? There needs to be a new way to think chips into some kind of NPU style, as well, more resembles the human brain than the GPU does now. Maybe it is just a lucky breakthrough that NVIDIA did, moving from a graph card problem into actually, that fits also to multi-query problems. So I don't know when we will peak, because what I see now is that we might slow down on the AI training maniac. When you build the big models, maybe you don't need to push that much, but then we come down to inference. Then how to run all these queries that we then punch through. And when we start seeing, we saw here the keynote Copilot really coming to work in companies, we'll start to see not only the training but also the running of the AI models to take over data centers. So sorry, I don't have a good crystal ball to say when that's going to happen. There are forces that are working in that direction, both on government, EU level, on technology level. But I do think we're going to see the next 10 years of a massive pressure from data centers.
How do you take into respect the security?
Yeah, so I was standing here and had a corporate career, and I was exactly met these American Norwegians that are building these here, and I asked that, and they said, listen, it weighs 60 tons, right? So in terms of stealing with a submarine, it's very difficult, and Esbjerg is a NATO-certified harbor and so on. You don't sneak in a submarine into it. There, of course, are cameras around and so on, but mostly that it weighs 60 tons, and you have to be a quite advanced diver to come down to do it. And then it comes down to also, you can also go into a normal data center, break in there. What as you see here is this is earthquake secure. That's why I'm moving quite fast in California, because you cannot place data centers close to the ridge, right? But with these here in the water, they can be there. The military, of course, it's very hard to nuclear bomb a data center on the North Pole, right? So there are some security benefits, but I do recognize that when we started building massively in the North Sea, who's going to come? But then I come from offshore wind as well. I'm thinking, what happens if someone would climb up on an offshore substation and the operator would look on a camera and say, what's going on here? Yeah, they would call the National Navy and say, could you send out a helicopter and figure out what's going on? But yeah, we saw the day before yesterday, the 2 fiber cables being damaged from Finland to Germany and from Sweden to Lithuania. Yeah, it is a challenge that I don't have a strong answer to, because yeah, how can you ever protect against such things?
Over here.
What will be the idea for rivers, as you mentioned in the beginning? Will dams be a proper candidate?
Yeah, in principle. As again, I thought that we would go and build large-scale offshore until a few German consultants said, listen, you're going the wrong way. You don't go offshore. Go into the rivers to be close to, well, people and so on. Build small edge computing data centers, but also to, and that's the next version come, that will have a shell around that will then be used for district heating. So yeah, it will emit, this one here will be 1.5 megawatts. So it will emit that heat into the sea. But yeah, why not capture that and build small district heatings along the river? And this is because I come from Denmark, where we have district heating like everywhere. While in Germany, for example, yeah, district heating is not everywhere. And this would be a benefit. So yeah, it can actually go, and for rivers, yeah, water comes by with a high current, it's perfect for it. So in the wintertime, you would close it off and actually use it as a boiler, right? Have pipes into the town, city, and then in the summertime, you will lift it up and you will let the water cool it more efficiently.
And you would also have a control from the dam, from the river flow. You can increase the body of the water to make the cooling better, right?
What do you mean?
If the idea is to have a dam nearby,
yeah.
Okay, so you would in the summer you would have a control of raising the river to have more cooling, right? Is that the idea?
No, you put it all the way down down on the river seabed. So out here in Donau, you just right here, you just place it down. As long as this water comes over it, then it's fine. But of course, if you have a power dam next to it, right? Of course, as an ideal location, because look at some of those locations in Europe, right, where you have power production right here, and then you have a river where you have built a lake, right? Yeah, why not place it there as well? And I think that's the strength of the technology, is that it can be placed pretty much everywhere in the world, as long as there is 4 meters of water depth.
Thank you.
Follow-up question. There's currently, aircraft carriers use nuclear power plants on board. So do certain large ships. And I think in Russia there's even a floating nuclear reactor. Could I take a few of these data centers, stick them on a ship with a nuclear reactor, and sail around the world to do illegal AI stuff across international waters? I'm asking for a friend.
Yeah, that's a good question. And there has also been other ideas out there where you place it on a barge as a raft, right, and place it underneath, and just can have your floating data center around. Also with floating wind, where you talk about this, in principle you could do that, yeah. But I also say that there are also, let's say, ethical limits. Again, maybe you hear a bit in these stories, it's about also doing good things. As in the cities, we will integrate with central heating in the 2 projects we'll do. We integrate with aquaculture, so tuna farming and so on. We have, of course, been asked by crypto miners if we want to go in that direction. It's a perfect idea for crypto miners. Place it in a Swedish river. But I must admit that we will not do that. That's let's say an ethical decision we have made, that we also will not. This is to do good, and not to Yeah. So if you're doing a crypto mining business here, yeah, you have to go somewhere else. That's a decision we made.
Do we have any more questions? Okay. If not, I want to thank Peter for his amazing talk. Peter, thank you so much.
Thanks a lot. Thanks. Thank you very much for listening.